Take a look at this 30-second video. The audio is narrated by me. Don't mind it. When understanding SV long video generation, let's first look at the basic single-image long video generation. We'll take the official workflow as an example. This is the official power workflow provided. This workflow is too complicated. Now there's a problem. Suppose I complete the entire workflow. I now feel that the second run didn't go well. I want to rerun it, but I have to execute the second one separately. I need to finish the first one before I can rerun the second. If I feel that the last one doesn't work right, I need to execute the last one, and that means I have to run through all the previous ones. Isn't that a huge waste of time? So I restructured this workflow in a simple way, still using the cache concept I mentioned before. Now I'll take executing 4 times as an example. The core here is that I created components with subgraphs. Let's dive in and take a quick look. This core is the reference video passed in each time. Taking the last few frames as the next reference image, I set the overlap frames to 1. This is the first time. It's a reference image. Then the generated video is cached. Finally, sampling again. Calling the cache and then generating the cache for the second time. The third generation takes the second cache and the rest follows the same. I won't elaborate on this logic. This can solve the problem we mentioned earlier. If I feel the third run isn't good, I can just execute the group directly without needing to run the previous ones. Next, I can change it into a loop. We only need to output the prompt word list. And the number of times to execute, to let it run automatically. This is the improved workflow. Here are the prompt words. The list where each line represents 1 execution. This is based on the cached video each time, with the prompt word currently being executed. Here's how many times you want to execute. I set it to 3 times as the main. Let's execute it and see the effect. Currently executing, let's see the first time. The prompt word here is from the first line. Currently executing, let's see the second time. The prompt word here is from the second line. Currently executing, let's see the third time. The prompt word here is from the third line. All right, execution complete. Let's check the results. This single image can theoretically generate a long video. However, if it's a fixed shot, and the scene of prompt word changes isn't significant, generating continuous videos is not a problem. Now, if my video generation has scene switches, or takes reference frames, like this, then you keep extending downwards, and characters from earlier reappear. Or the main subject. The model doesn't know character subject at all. This way, isn't it difficult to ensure character consistency? So generating long videos individually won't work for some scenes. That's why I've used beginning and end anchors to handle this. This can improve quality, while also ensuring the subject doesn't change too much. Next, let's take a look at how this workflow is implemented. Here are several storyboard images I uploaded. There are many ways to generate storyboard images. I won't elaborate on that. For this test, I use 6 images. Here, you can set the image list you want, and the number, mainly focusing on the loop below. Each loop retrieves the first and last frames to combine and pass to the large model for prompting. Finally, into the front space, then sampling to generate video. I have uploaded the workflow to RunningHub. In the conf UI field, RunningHub is a fantastic online workstation. As new models and extensions appear, it will follow up immediately. It will follow up at the first opportunity. You can register for RunningHub through the invitation link in my video description. This way you can get 1,000 free points. Additionally, by logging into RunningHub every day, you'll also receive 100 bonus points. This way, you can try running your own or someone else's workflow. All right, that's all for today. If you like it, please give a triple support.